So if it's okay with you, then we'll dive in this first session where we'll sort of talk in a very big picture way about what BIM is. We're starting really from the point of view of zero knowledge, so don't worry if you're not too familiar with things. We'll explain it all as we go through. So BIM essentially stands for Building Information Modeling. It is a process, Lisa touched on that earlier on, it is a process which is basically collaboration. It's all the parties, different teams, different disciplines working together to deliver projects more efficiently, and that's really the core of it, is that efficiency. The entire team is included, and this is sometimes people, I think, don't think that the client is included. The client is probably the most important person, because at the end of the project, when we get to the handover stage, the digital information that the team have produced is effectively the handover information. That is what the client takes. You may have heard the term digital twin. It's a kind of the current buzzword, certainly in the UK, for digital handover information. That the digital model that we've built as a team between the designers and the contractors gets handed across to the client at the end. So everybody's involved, the whole supply chain are involved as well. And we'll touch on how that's managed, particularly from a main contractor's point of view later on. So as I said, in sort of after your presentation, the whole project is built digitally in a 3D model, and effectively that's the prototyping stage. So the 3D model, typically it's a 3D model is built on the computer before it's been built on site, and you can iron out all of those challenges that traditionally come up where things don't fit. And that can cause delays, it can cause more cost on site, and more materials and more waste, which is obviously what we're keen to avoid. Other key factors to do with BIM is information sharing, and we'll talk quite a lot about this today. As you've said, traditionally there has been a lot of silo working, so basically everybody working on their own bit of the project without necessarily talking to other people. Traditionally that's how construction works, and I'm speaking from a UK point of view here as well. It's definitely how it's worked here for a long time. The benefit with a BIM process is information is shared earlier and more frequently. So this central model that everybody can see and access is continually being updated as the design develops. So everybody has an understanding of what is going on as design develops. So for example, if the architect makes a window wider or smaller, that will impact on the structural design potentially. The structural engineer will see that change sooner rather than waiting for the architect to reissue all of their drawings. So that can be caught quite quickly and maybe be highlighted by the engineer as a risk or a challenge. The 3D model contains more than just geometry. So the geometry is obviously the size and shape of the building or the road or the roundabout. That is the physical side, but equally it contains data or non-graphical information. It's a really important part of it that no longer do we have a set of drawings that show the geometry and the size and the relationship between all the elements, and then a separate specification document. All of that information is in the same place. So it starts to make discrepancies reduce because all the information is consistent and in the same location. And again, we'll explain how that's done later on. From this is probably more of a personal one. From an architect's point of view, one of the most time-consuming exercises that we would normally do before construction is prepare schedules and produce information about how many windows we have, how many doors, how many sills and different profiles that we might have for different elements. Because the software is clever enough to understand all of the different elements, it knows what a wall is, it understands that a wall is made up of layers, to kind of construct the wall. It understands what structure is, it understands the difference between a steel beam and a concrete beam. All of these elements it knows. So it's very good at producing those schedules and information out of the model that can then be interrogated by the team to understand exactly what has to be built. It also means that it's harder to take shortcuts. Quite often, again, in a traditional workflow, it might be quite easy to just do something quickly, cobble together a quick drawing and send it off. the model doesn't really let you do that very as much, because ultimately the risk with doing that is then it doesn't update everywhere else. If you do it in the model, it updates everywhere and everything is caught, everybody's aware of that change, and so it facilitates a better workflow to understand what's going on. So this is a definition that was produced by the UK BIM Task Group, which has since evolved into another organisation in the UK, but this is how they have defined BIM, certainly as it applies in the UK, and it's a useful coverall statement, I think, and in fact I can't see it all because I've got windows in front of my screen. Here we go. So BIM is essentially value creating collaboration. So we're collaborating together to create that value within the project through the entire life cycle of an asset. And the asset could be a building, it could be an infrastructure project, it could be a bridge, it could be roundabout. All of these things would be classed as an asset. And the key thing there is the entire life cycle. So it's not just design and construction. As I say, the client takes the digital information after handover, and that value is retained by the client to use to maintain the asset, the building or the structure. All of that is underpinned by the creation, collation, and exchange of shared 3D models. So those are the models that we'll have a look at one later on and show you how it works. And the intelligent structured data attached to them. So that's the geometry part of the model and the data specification side, I suppose, that all sits together. So that hopefully that makes sense to you as a statement on what BIM is. Effectively, that is what when we're talking about a BIM project or projects working with BIM, that is ultimately what we're trying to aim for. I do think it's useful to explain sometimes what BIM is not. So some people maybe have a poor conception of what BIM is. Some people think that it's just 3D CAD, that it's just effectively what we did in 2D, but it's 3D now, and it's just still a model. It's not just 3D CAD, as we'll see. There's an awful lot more to the process and also the information as well. It's not just a piece of technology or a piece of software. It's not something that you can just buy and then deliver a project in accordance with the BIM standards that we'll look at. So it does take a bit of time. It takes work. There is training. You will need to train your team on that, your suppliers, your subcontractors. Everybody needs to understand the same process and that ultimate goal. And it's quite a common thing in the UK for people to confuse between BIM as a process and Revit, which is the Autodesk software that is used to build BIM models. Revit is the market leader in the UK and I think in America, and it is, I think a lot of people think if I use Revit then I'm doing BIM, and that's not necessarily the case. There is an awful lot more to it than that, as we will see. So ultimately, the goal of a BIM process is to have this, what we call the single source of the truth, that we're trying to achieve one model, one location where all of the project information is kept to do with the building, but also to do with the process and decisions that have been made and so on. All of the briefing documents, all of that information effectively is in one place, that therefore you shouldn't have those discrepancies between different parts of it. So the key principles, which we're going to run through today, this is how I've tried to break it down. We're going to think about what we are sharing in terms of the model. So that's the geometry and the data. We'll break those down and think about them in a bit more detail. We'll think about how we are going to share that information. So we'll look at something that's called a common data environment, which is effectively the location where all of this information will sit and can be exchanged, and the standards as well, which underpin how we all collaborate and how we exchange that information consistently as a team. And then lastly, after the break, we will have a look at why we're sharing it, what are the benefits of using this process, some case study examples of where this has worked well, and the benefits that those projects have found by following the process. So we'll start with the what. What are we sharing? So from a BIM process and a typical BIM project, you'll really get three elements that will come from the process. You'll have your model or a series of models that contain the information. We still have drawings. Drawings haven't gone away. The difference on a BIM project is those drawings come from the model. So they're all consistent, it's all coordinated, and all of the information comes from that single source of the truth. And then the last thing, as we talked about, is the non-graphical data, the information that's in the model that is not to do with the size and shape of something, but more to do with the construction of it, or the attributes that that element would have. And we'll look at each of these in more detail just now. So the 3D model, this is a screenshot from a model that we can have a look at later on as part of the kind of demonstration. This is done in Autodesk Revit. So this is the same software manufacturer who produce AutoCAD. So hopefully it won't be too unfamiliar when we start to look at the model later on. You'll be familiar with the way that the tools are set out and those sorts of things. But really it is the main tool. It's the one that we use. It's the one that I use for demonstrations because it's what we use in our office. But there are other software packages available. It's not, Revit is not necessarily the best for all projects. I think it's very good for buildings. And as I say, as an architect, that is our primary output, is building design rather than infrastructure. But I do know of other ones that exist that might be better for linear infrastructure projects. We can talk about them. The biggest challenge with models is what format that model is built in. So with lots of people building models for their own packages, so if you've got an architect's model and a structural model and a civil model and a mechanical model and electrical model, maybe an interiors model with the furniture, you might have a survey model from an existing building. All of these exist as different files. The challenge then is, how do you then join them all together? How do you share those and kind of create this single model that we're going to refer to? So there are two terms that really come up when we're talking about model formats. The first is native. The native format is the version that the software likes. So for Revit, it's an RVT file format. The other ones that are on the screen here, we've got Archicad, have a BIM modeling package as well from Graphisoft. We've got EcoSim from Bentley. Bentley was developed more from an infrastructure point of view, so Bentley have done a lot of work in the past on railways, bridges, those sorts of projects. So I think I haven't used it, but I believe that EcoSim is a platform that is primarily designed for infrastructure projects. Other ones that are on here, Vectorworks, Tekla, and Trimble, are other tools that exist that can build models that people can exchange in a BIM project. So the challenge is, if you have different members of the team using different platforms, how do you then share those models and exchange those so that you understand the design and what's happening? Well, the primary way that we do that is through an open source, non-proprietary file format. I'm not sure how well that translates. Effectively, it is a file format that isn't owned by one software provider. It's a file format that all of these packages can import and can export. So if you have one member of the team who's working in Revit and producing Revit files, and one member of the team who's working in EcoSim, say, to produce their models, those two files won't talk to each other by default. What you have to do is export them into what we call an IFC, which stands for Industry Foundation Classes. IFC format that basically each of those packages can open and understand. So that's how we collaborate across the different platforms, is using something called IFC. IFC is the primary file format for doing that. The other file format that you might come up against is a collaboration file format. So NWC is the Navisworks. Navisworks is, again, the Autodesk software that is used for overlaying all of the models, joining all those models together, running what we call clash detection or interference checks to make sure that beams and ducts don't occupy the same space, that there's enough space between them. The software that we would use for that is called Navisworks. And it has its own file format. So once you've overlaid all of the models on top of each other, referenced them in together, that model can be saved as a collaboration file, where again, it's easy to then pick them apart, update the individual models as they're revised by the team, and still produce that coordinated overall picture. So 3D models, well, again, we'll have a look at one later on, but this is effectively the kind of key things that you need to think about when we're talking about 3D models, and particularly interoperability between different file formats, because it can be a big challenge on a BIM project. 2D drawings, as I say, 2D drawings haven't gone away, and certainly in the UK, it is still drawings that are taken onto sites, and actually when you see the workers on site, they're not working from tablets and iPads, they're working from drawings. So the actual construction still happens from drawings, but the benefit of a BIM process is each of these drawings comes from that 3D model. And we'll show you later on how the 3D model can be used to generate some of these details, schedules and drawings. So that again, it all comes from that same single source location in the 3D model. And the notes and things can pick up on the data in the model as well. So it relies less on typing notes, which again might have an error. Actually, if it's looking at a particular, let's say the note is pointing to some brickwork, it's maybe looking at the specification of that brickwork, the data that's in there, and showing that on the drawing. So if you change it, if the specification changes, all of the notes will update automatically. And then lastly, the third element is the non-graphical data. And again, so you can see in this screenshot that we've selected, this is a ceiling hoist in an accessible changing room. So this is a hoist that might be used for someone in a wheelchair. And you can see on the side there, the window that shows some of the data that you can assign to that element. So, and the information that you can assign varies depending on the element that it is. So for some, it might be, in this case, it's to do with tracks and hoists. It's about how it's powered, it's how it's classified, but it might equally be for a door, it might be the fire rating, it might be the ironmongery, the finish of elements as well. All of that exists in the model so that it's in the same location and everything is consistent, easy to check and easy to update ultimately. The other thing to think about with non-graphical data is not so much just what's in the model and what happens when you click on it, but equally, how do you then exchange that information? How do you share that data, the non-graphical information, with other parties on the team? And the primary way that we do that consistently is through a format called COBie. So COBie stands for Construction Operations Building Information Exchange. It's very catchy. But ultimately, this is a big spreadsheet. What it does is it takes the information that is in the model, exports that into a spreadsheet, and it's just in Excel. It's not any special software, but ultimately, it's a consistent way to explain and share the information related to the construction project. None of the software is clever enough to know what you want, what you need to put in the building. That has to come from the people. But you're right, if the people miss something and it doesn't appear in the model and it doesn't appear in the spreadsheet, then you can't blame the software for that. That has to come from the people that have designed it. So you're absolutely right. The information that you get is only as good as what has been put in at the start. And if it's not been put in properly, then there's an issue. When we come to look at things later on this afternoon to do specifically as a main contractor, we'll talk a little bit about how the information can be checked before it is, when it's produced, it is checked to make sure that it is accurate and that there are no errors and nothing missing, because there is a process again that should be followed for that to make sure that everybody has checked that it's correct. But yeah, if to come back to your original point of being able to produce a bill of quantities from the COBie spreadsheet, if the information can't be trusted that is produced and issued, then there's no point in producing it, really. If the COBie spreadsheet is in doubt as to its accuracy, then it's worthless. The only benefit that comes from this process is that everything is consistent, everything has been checked, everything is coordinated so that you can trust it. And you can use that to produce other documents. So hopefully that helps. So yeah, I'll kind of rattle through this quite quickly then if you're already familiar with COBie. So it was developed by the US Army as a kind of universal classification system. We in the UK, we have a British standard that defines how we use COBie, but it's really you're probably familiar with NBIMS, which is the kind of international American-led COBie organization who maintain the spreadsheet and explain all the fields and how it should be used. When I first show people a COBie spreadsheet, if they haven't seen one before, they get very worried. But if you've seen one before, it's great. It looks really complicated, but really it is just a structured way of showing information that comes from the model that's not graphical. So it takes all the data and it puts it in the same kind of format. From a main contractor's point of view, there are some useful things to bear in mind in terms of COBie. Usually the data is added as the model is built. So pre-construction at design stage, designers will put in information that they know. So if we take the example of a door is a good example to use. At design stage, you'll know what size the door is. You'll know what if it has any glazing in it, if it has what ironmongery you have, fire ratings, finishes, those sorts of elements. So that all goes in pre-construction, so that element can be done. Once you get to installation, additional information is sometimes needed as well. So the COBie spreadsheet does have fields for installation date. It has fields for warranties. So again, when it's handed over to the client at the end of the project, the client understands when certain things have to be replaced or maintained throughout the building's life. So during construction, certain other information needs to be added either into the model or into the spreadsheet just in Excel. So again, it's something to be aware of. Most contractors in the UK would outsource that exercise to the consultants. So the way that the standards is written is the contractors are responsible for the accuracy of that information, but most contractors in the UK certainly don't have the skill set to be able to edit or update a model or the spreadsheet with confidence, so they tend to outsource that back to the consultants that have produced the design, who are retained. It might be slightly different the way that it works for you, that if people are involved all the way through, then it might be a simpler process. But for here, there are sometimes contractual implications of who's responsible for these things, who takes liability if they're incorrect, becomes quite a legal challenge effectively to a lot of projects in this country.
I can just give a comment about this very quick.
Of course.
In Macedonia, the legislation for the law for construction, we have when a project is designed, you have a company that does the design, and then you have like another company which does a revision of the design. So it's sort of like an audit. And after that, each and every project has to be designed by one company to pass the audit, the revision by another company. And after that, we have another institute for earthquake engineering, it's called. They're basically controlling all of the projects for tall buildings in Macedonia. And after they give the green light, the project can get the necessary approval and get the building permit in order to be done. So just a comparison for the liability that you mentioned.
No, that's really useful. So we have a similar, in many cases, a similar process here where the design is usually carried out. It's approved by our local authority, who would check all the data, the information, to make sure that it complies with the regulations, and then it's constructed. And at the end of construction, the company that, or it can be a separate company in England. In Scotland, it's the local authority who will come out and inspect and check to make sure that it's been built according. So it's probably quite a similar process, just with slightly different parties involved. The key thing from COBie, certainly, and this is developed from, as Lisa said at the start, our UK presentation, where COBie can be quite a challenging thing from a contract point of view. The key thing is just to make sure it's all agreed, defined at the outset, who's going to be responsible for doing what. And if, as a main contractor, you have subcontractors or you're appointing people to do things on your behalf, just to make sure that that's all very clear. The key thing with COBie that I think a lot of people miss is that really it's only for maintainable items. So everything that is built in the project doesn't go into the COBie spreadsheet. So for example, most structural elements won't appear in COBie because there's no maintenance requirement for structure. Most things that go into the COBie spreadsheet tend to be mechanical and electrical, but like I say, doors will go in, elements that need maintaining, replacing, or checking periodically. So any kind of life safety systems will definitely appear in there. Anything that requires checking, periodically, like for doors, it could be fire doors will need closers to be inspected and checked, these sorts of things, test certificates to be updated potentially if work is done. As I said before, installation warranty information should be captured on the spreadsheet because that gets handed over to the client. And the key thing is that the as-built information has to match what what has been built. There's no, again, in order to trust the data that is handed over to a client at the end of the project, it has to be accurate to what's been installed. And quite often it's the bit that in a rush for handover to get the project handed over at the end to the client, quite often this is the bit that people neglect, and it doesn't get updated quite as accurately as it should, and it gets caught as part of the check process. So a couple of other terms or concepts to be aware of as we're starting to think about building a model and a model that will evolve. As you will all appreciate, at the start of a project, you start at a very sketch proposal stage. So you're doing an initial design, it's quite conceptual. And as the project evolves towards construction, it gets more detailed and more accurate. And it may be that different parties, as you've explained, are responsible for different stages. But one of the key things on a BIM project is to explain what's expected at each of those stages. How complex should the model be? And we split those really into two terms. We've got level of detail and level of information. The level of detail is how something looks in the model, how accurate it is graphically in terms of its geometry. And the level of information is how much detail is in the non-graphical side. So how much specification data is there. So again, if we use an example of a door, it might be at a very early stage, you know that you need a door to a room, but at the moment you don't know what finish it will have, you don't know what fire rating it might need, you don't maybe know if it's going to need a particular set of ironmongery for the handles. That's not been worked out yet. That's quite a low level of detail. But as it evolves and you get closer to construction, being able to order all of the components that you need, all of that information has to be there. So it's quite a kind of progressive process of adding more information and detail to the model as you go through. In order to make sure that that's controlled, usually the level of detail and the level of information are identified right at the very start. So when if you're let's say I'm the architect on a project, part of my contract and my appointment will be, this is what we expect you to produce. So at this stage of the work, this is how complex we expect the model to be. So you fully understand what you're expected to deliver at all stages. In the UK, we work to a sort of level of definition framework that has been produced by the NBS. So NBS have a website, so you can have a look at this website yourselves. And what it basically has is a massive library of building components, elements that would happen in construction. So the example on the screen here is for a door that you can see as the stages work down the screen. You can see the diagrams get more complex and more detail is added in. So you know if you're working to a concept stage, this is the level of complexity that you're expected to have within the model. And hopefully it just removes any misunderstanding of what is expected at a particular stage. The other system that you might have come across or you may be familiar with is an American system, which is known as the level of development, LOD 100 to 500. It was developed by the AIA. And again, the BIM Forum website that's on the screen there, they produce, on an annual basis, they produce a big book, basically, a huge PDF that explains for a whole range of different construction elements and components what each of these 100 to 500 actually means. What does that look like on a model? How complex is that in reality? And as you can see, it kind of evolves in complexity as you go from concept stage up to facilities management, being able to maintain that element, whatever it happens to be. So those are really the two systems that are used to define how complex models become. So just before we kind of break for coffee, we'll have a think about how we share that information. So some of the principles in terms of how we actually, we understand what we need to develop in terms of a model and how that model is going to have all the data in it and produce the drawings from it. How are we actually then going to share that amongst the team? So traditionally, information would be shared by email or it would be sent to other parties on the team. There are a number of challenges which I'm quite sure you've come up against, that either you have technical issues like file sizes being too large, errors in the system, not being able to accept through firewalls and other IT problems. Similarly, the other challenges that you tend to have is that people are not necessarily always working to the most up-to-date file. It relies on the recipient's filing system to make sure that they keep on top of it and that they understand that if you've sent them a revised drawing, that supersedes the previous one. Or that can be quite confusing. And I have run out, I can't count how many times I've spoken to a contracts manager on site who's working to a drawing that's out of date. When they tell me that something doesn't work the way they expected it to, you ask them what revision of the drawing they're working to, and they're working to 2 or 3 revisions out of date. It happens all the time on a traditional workflow, and I'm quite sure you guys are the same. So the principle of this common data environment is to try and bypass all of that inefficiency and the risk that comes with that as well. So the principle of a common data environment is more like this diagram. And these are diagrams produced by Autodesk to explain how the common data environment would work. All of the project data exists in one location on the cloud that then everybody can access from their own computer if they're in the office, or mobile devices out on site. So everyone is able to rely on the most up-to-date information. As soon as, for example, as soon as the architect updates their model, their information, they share that back to the cloud. Everybody can then see that instantly. Everybody knows if they're looking for the latest information, that's where to look. They don't need to rely on their own internal filing system or process, because they can look at the information that has been put there by the party that has created it. So it may be the electrical design, it may be the mechanical design, whatever it is, it all exists in the cloud and everybody can get access to it. This is another diagram which I think is quite alarming in many ways, to explain the difference between traditional information sharing, where all of the parties are sending stuff individually to everybody else. And the biggest thing that occurs to me here is it's so easy to miss somebody out of that distribution. And quite often the person won't get a copy of whatever it is for because of a mistake. The common data environment bypasses all of that because it's got the central location where all of the project information is kept, and everybody can interface with that as they need to. So if they're needing to check something's up to date, they can do that instantly. If they need to share information, they can do that straight away as well. These diagrams were produced by the Scottish Futures Trust, who have a really useful BIM resource library online as well. It's one of the ones that I've got on my list of links for later on to kind of show you further reading and other resources, because there's some really great explanations of how the process works on that website. So there are lots of benefits that come from sharing and exchanging information in this way. These are some of the key ones that I'm showing on the screen just now. I've touched on a few already. Information is continuously shared. Because it's checked before it is shared onto the common data environment, it can be trusted. So again, it comes back to that question that you raised earlier on about, if I get this database, can I do something with it? Yes, you can. The way that you can trust it is when information is published to a common data environment, it's what's the word, I suppose, tagged as a certain for a particular purpose. So it's very easy if you were, let's say you're the civil engineer and you want to go in and check the latest structural model for the foundation layouts. If you want to go in and check if that model is is ready to be relied upon, if that design has been approved, signed off and checked, the model, the information in the common data environment will tell you if it's still work in progress and it's maybe still in development, or if it has been checked and approved and coordinated, and you can then rely on that. All of that is managed by the system. Other things here that are useful is permissions can be controlled. So again, people can only see the information they need to see. We'll talk a little bit about security later on, but it's all managed through this platform, where if you have a large team and it's a very complicated project, and perhaps it's a building that is sensitive in terms of its nature, maybe it's a prison, or it's a Ministry of Defence a facility, that some of the information might be sensitive and not everybody in the team needs to know everything about the building. You can control who can see what. So again, you can build in mechanisms that actually certain parts of members in the team might not be able to see certain parts of the information because they don't need to do their job. So that can all be quite easily controlled. I'll not run through I'll send you all of these slides. In fact, I think Lisa may have already shared them with you earlier in the week, but this will all be made available to you. So don't worry about trying to copy down all the bits on the screen just now. But I think that you probably get the idea of how that works within the common data environment and sharing information with others. Autodesk have their own version. So those diagrams that I showed are from what they call, their platform is called BIM 360, which you may have come across, which is effectively that kind of cloud-based location you can share project information with other people. But there are a whole range of different providers that can offer this solution. Another factor in terms of how we share information is the standards. What standards do we work to? It's really, really important that we work to a consistent standard across the team. If you've got one party in the team who is naming files in their own fashion, exporting files to their own settings, maybe showing and representing information in the model or on drawings to their own standards and not to the same standards as the rest of the team, that can get really confusing, really complicated, and people don't then know what certain information is, what it can be used for, and so on. So it's fundamental that everybody in the team works to the same standards. And just recently, in the last few years, there have been an increasing number of international standards that have been produced to explain and make sure that that's consistent across teams. So these are the 4 key ones which have been released so far around about the delivery of projects to BIM. ISO 19650 Part 1 covers concepts and principles, so it has things like the common data environment, how that works and is managed, how you then exchange information. Part 2 is around about the delivery phase of assets, so that's design and construction. Again, it's how do you then create files, name files, and structure that information for sharing with other people. Excuse me. Part 3 is about the operational phase. So that's how the asset is used after it's been constructed. So it's more around about maintenance, how the digital information is used. So it talks a lot about the handover information, how you map that, how clients can create that information that they need. It also talks about what happens when you have an existing building that you need to carry out another phase of work to, or do improvement works or an extension or an alteration. How does that fit within the BIM process because you've already got an existing building? That's covered in Part 3. Part 5 is the one that I kind of touched on there, which is about security of sensitive information. So it's a structure, it's a framework. It doesn't tell you the nuts and bolts of how you make things secure, but it gives you the framework around which to decide what has to be secure and how that information can be partitioned off effectively to make sure that only the key people have access to the information that they need to see. So this library is growing all the time. There are more standards than I have on the screen, and if I was to talk about them all, it would take the best part of the day. But it's really just to kind of explain to you, there are a number of standards out there that basically underpin how we do collaborate within the same project, how we name things consistently, how we share information in the common data environment consistently, so everybody knows what the expectation is and what they have to achieve. In the UK, and I think in other countries, there are, to some of these international standards, there's a national annex. So we have in the UK a national annex to each of these, which basically takes a bit more of a step towards the nuts and bolts, the practical things that you need to do. It defines how things should be done in the UK that fit more around about other UK regulations and legislation. How does this then fit in with other UK policies that we have in this country that, again, are quite often delivered to BIM? So each country has their own flavor, I suppose, of these. It takes the principles of the main international standard, and then it says, okay, that's how we need to share information. This is how it's going to work in this country. And again, it just gives people a little bit more of an understanding of exactly how is that going to happen in practice. In the UK, we do have a number of specific standards, and again, this is built from the UK presentation. We have that one about COBie, which I had mentioned previously, around about how COBie should be used for construction in the UK. We have a document around about health and safety information. So we have a standard. Obviously, health and safety legislation is quite rigid in the UK and across Europe, of course, and it is easier to build that into the model because, again, it's just data. It's just having more of your information in the same place. So rather than having your model and your drawings in one file and then a separate health and safety document sitting somewhere else, all that information can go in. And what it means is you can effectively, you can tag the components in the model with the health and safety information. So it might be, for example, that you have a particular, maybe you have a particular site where there's a lot of excavation risk. Maybe you're working underground. Maybe it is maybe a subway station or something like that. You can add and build in physical or digital representations of those health and safety risks. So you can put in warnings that identify to people, here's the risk here, this is a risk assessment that you need to carry out, this is a method statement that you should follow. Similarly, if there are particular components that are heavy or risky or maybe installed in a difficult location, tricky, awkward, confined spaces, you can tag those components so that it flags up in the model to say not just how big it is and where you order that from, but also here is the health and safety information to be able to install it safely for the operatives. All of that can be captured in the model, and we have a UK, I believe that one is being developed into an international standard, but it's still quite a new one for us. It's only been out for a few years now, so it's one that is bedding in. And of course, because all of that health and safety information exists in the model, and we go back to our scheduling, extracting data from that model again, it's really easy to pull together full separate documents that show the health and safety risks and information in the model. And equally, that can be updated as you go through construction as well. That can be kept up to date. So if there are any incidents or if anything changes, that health and safety information remains accurate and up to date at all times. Another couple that I've put onto the list, which I believe there are international standards for, although I've not necessarily used them because we're following the British standards in the UK, are Code of Practice for Facilities Management, either in buildings or in infrastructure. And again, these are the documents that start to drive the type of data that we need to capture to allow the client to then maintain the asset after handover in terms of them managing that facility. There is some really great guidance on the standards that has been produced. There's a group of companies in the UK called the UK BIM Framework that are taking each of these international standards and effectively making them easy to understand. If you've ever looked at standards documents, they can be quite difficult sometimes to really understand how they work in practice. So what the UK BIM Framework are doing are taking each of the international standards, the ISO documents, breaking them down and explaining exactly what has to happen, using case study examples as well. They'll use examples to illustrate how things might work in practice. and ultimately kind of helping people to put together their own project-specific documents that fit the international standards that we're trying to work to. It's all available for free. It's all available online. I would definitely recommend having a look. It's not, although they're branded UK BIM framework, it is about the international standards. So they do cover those same key documents that would apply to BIM projects elsewhere. So that kind of covers a bit about how we share information, the common data environment, and the standards that underpin how we then all do it consistently and in the same way. We're going to break just now for a quick screen break, because I'm always aware when we do these things that you spend an awful lot of time sitting in front of a screen, and it can be quite challenging. So we'll take a wee break just now for 10-15 minutes, grab a cup of coffee or something. And when we come back, we'll have a look at why we share information. We'll look at the benefits that apply to different types of projects, some case study examples of where benefits have been realized, and then we can kind of explore some other bits and pieces. Before we do break, does anybody have any other questions on that? Anything that we've covered at the moment? Anything that wasn't clear that you would want me to recover? Is it coming across okay? I'm trying to speak quite slowly and make sure that everything's quite clear to understand. But BIM is a when I was asked to deliver this and deliver BIM internationally, my heart did sink a little bit, because there are so much terminology that's unique to BIM. The standards have so much jargon in them that they've created new words for so many things that we're all familiar with, that it's difficult enough trying to explain it to an native English speaking audience. To try and do it internationally, it's an extra step of a challenge. So hopefully all the information makes sense that we've covered so far. As I say, if there are any questions, feel free to shout.